Hello, psychology students. This week we're going to talk about cognitive development. Our main theorist we're going to focus on, his name is Jean Piaget. Okay, French. Ho, ho, ho. So let's get into it here. First thing I wanted to kind of prep you for, you're obviously going to need notes, right? Because you're talking about something new here. Two words that we're going to be using a lot this week. One is cognitive, and that means thought or thinking. So whenever I say cognitive, what you should remember is thought or thinking. And the other word is called schema, and that's a cognitive term, a cognitive psychologist term for an organized pattern of thought or behavior. So it's like a group of thoughts together. That's a schema. And usually these group of thoughts describe something in the world. If that makes sense. And you'll see kind of how that works in a little bit. But the question we're trying to answer is right over here, right? How thoughts are formed and how we make decisions. And in order for us to get into that, we have to know these words, right? Cognitive is going to be thoughts, right? Another word to say is cognitions. You want to be really technical and psychological about it. And schema are a group of thoughts together. Schemata. Pretty cool words, right? So here's Jean Piaget. Look at him. I love this picture of him. He just looks like such a fun person, doesn't he? He's like sitting forward and he's all like, "Oh, I'm going to tell you something cool today." So I dig that. Okay, but Jean Piaget, this is the guy, the theorist that came up with these kinds of ideas. He really wanted to know how people organize their thoughts and how they came up with thoughts in the first place. So here's the first part of his theory. Part one is that with schema here, an organized pattern of thought or behavior, and he says that everybody has, like a whole bunch of these things. And he says this explains how children learn and acquire language. It explains how people learn and understand the world around them. It explains almost everything in the world that people know and can do is covered by his theory. And he says people need two things for this theory to work. Two. One, biological maturation, and two, environmental experience. So he says that you are growing, right, and your brain is changing. So remember last week when we were talking about the difference between the nativists and the empiricists, right? The nativists believe that you have a device in your brain that develops over time, that makes it easier to learn, and then the empiricists believe that you learned through input from your environment, right? So Piaget is going to take these two ideas and he's going to put them together. So those of you last week that were really struggling with, well, I think they're both kind of accurate. This guy's for you. So he says everybody needs two things. So let's talk about schema. The many schemas are called schemata, right? You can like amaze your friends and your parents now with the awesome words you know. Blow their minds. So all the schemata together, they make up your worldview, right? So if one schema is an organized pattern of thought or behavior, many schema together, once you put them all together, that's what you consider to be your worldview. And the other thing that he would say was that the people notice new info all the time, right? And it really only sticks if it fits into their existing schemata, right? So if it already fits into what your worldview is, you tend to remember it better. This is what we're going to be talking about in the webinar for this week, is why this is true. And he would say that, the reason why, it helps your memory and your attention is because when you notice new things that already fit into established patterns, into buckets you've already created in your mind, it helps your memory and attention because it just fits right in there, right? Just like a little piece of a puzzle, And so he would say people notice new information if it fits into their already existing information. And that makes sense, I think, to most people. Hopefully it's making sense to you right now. He would also say that people have a difficult time when there's new info that doesn't fit into that schemata, right? That contradicts it. And people tend to dismiss new information, no matter how good the fact or statistic or story or information might be. They tend to just dismiss it. And this is what leads to stereotypes, right? And prejudice. Is because the new info that's trying to get in there, trying to, replace your schemata, your old schemata, maybe break it open, maybe reform your old schemata, it just doesn't get in there. Because you already have formed, some ideas in your mind about how things are in the world, right? And this is what we're going to talk about during our webinar this week. He has two big ideas that have to do with thoughts forming in your mind. One is called assimilation, and the other is called accommodation. Assimilation is what we were just talking about, taking new information and putting it inside your already developed schemata, right? So like you already have an idea of, I don't know, let's pick a topic, whether drugs are good or bad for you, right? We can be as specific as we want to. Let's talk about marijuana, right? Whether we think marijuana is good, is a overall benefit to people in society, or whether it's an overall really dangerous thing in society. So if you get new information, right, about marijuana, let's say we get a fact like for people under 20 years old, it creates lesions in the brain, right? Now, if you're a person who is already sort of pro marijuana and you get that fact, you're more likely to dismiss it, right? Because it doesn't fit into your preconceived idea of, like if marijuana is good or bad. If you're a person who believes that marijuana is this horrible social destructive force, you're going to take that information, you're going to be like, oh, hey, I knew I was right. And then you're going to start repeating it to all your friends, right? Man, you shouldn't smoke marijuana. You know why? Because it gets lesions on your brain, right? So that's how assimilation works. The opposite of that is accommodation. Accommodation is when you take new information that doesn't fit anything else and sort of make a new schema, right? So instead of like fitting it in like a puzzle, you're sort of twisting it around and molding it to something new, right? So let's say this situation again, right? You are somebody who's pro marijuana, right? And you're like, man, marijuana is fine. It's not even as dangerous as alcohol, right? And then you get this fact in that maybe they've just done this study, right? That says that anybody under 20 is in grave danger of developing lesions on their brain, right? If you can take that idea and fit it into your preconceived notion about marijuana and come up with something new, that's accommodation, right? So say I was, pro marijuana and I hear this thing, then I'm like, well, okay, so now I'm going to be maybe I'm going to say something like, well, marijuana is generally speaking, better than alcohol for, most people above the age of 20, let's say, because of this new study, right? That's how you would do accommodation. And then if we were backwards, right, if you thought that marijuana was this horrible social destructive force, and you heard information that said that like marijuana was not as destructive as alcohol, you have to put those two things together in order to make an accommodation, right? So then you would say, well, okay, so just because marijuana is not as bad as alcohol doesn't mean that it's good for you. That would be an accommodation. Okay, so let's talk about his stages, right? Because he said that, remember the first topic that we talked about with Piaget was that your brain develops over time, right? So he's going to have stages, right? There's going to be one stage, then the second stage, and the third stage, and the fourth stage. And you're going to move through these throughout your life, or most people will. We're assuming people don't have any cognitive disabilities. And we're assuming that, people don't have traumatic brain injury or, those sorts of things. Okay, so he's going to say that each person undergoes changes over time, right? Part of it's biological, right? Part of it is that the brain develops as you age. So, you're going to go through these stages, generally speaking, from younger to older, right? And then he would also say that the changes are partly environmental, right? So the more new experiences you have, the more you go through this process here, right, of assimilation and accommodation, right? The more new experiences you have that either fit your preconceived ideas or you make new ones, right? So he says people undergo changes, either biological or environmental. It's kind of an amazing process, It's kind of like the language piece that we were talking about last week. Kids start by learning to separate themselves from their environment when they're really little, and then they end up being problem solvers and reasoners, and they can use deductive reasoning and be like little detectives figuring things out. It's a really cool process to see somebody go through. Okay, so here are all the stages. We're going to go through these individually, but I wanted to kind of show you I don't know, like a broad spectrum of like what it would look like from beginning to end first. So the stages are here, right? Sensory motor, pre-operational, concrete, and formal. Now you can call it concrete operational or formal operational if you want to, but I think it's easier just to do sensory motor, pre-operational, concrete, and formal. But that's how I remember them. And you're going to move from birth at 0 here, right? 0 to 2 years for sensory motor, 2 to 7 for pre-operational, 7 to 11 for concrete, 11 and older for formal. Now these are just kind of guideline years. They're not necessarily set in stone. Some kids move faster because they have really high cognitive ability. Some kids move slower because they have lower cognitive ability. But if we're looking at a normal curve, of people, generally speaking, these would be the ages. And we're going to go from understanding the world through your senses, and like physical experimentation, like touching things and listening to things and putting things in your mouth and all the things that little babies do and toddlers do. And then we're going to move through until we get to a time when you can use logic and you can draw conclusions based off of facts and statistics and testing out hypotheses, right? So first you start in putting things in your mouth because that's one way to make sense of the world, and you end up with having all these experiences throughout your life, and you develop logic and you can understand all sorts of interesting things, right? Because you all are in the formal operational stage right now. So sensory motor, like I was saying, we're just sort of learning about ourselves and our bodies and how they move, right? You have to get this idea of object permanence, which we'll talk about, to move on to pre-operational stages. In the pre-operational stages, you start to learn language, right? And you know a little bit of symbols. Everything is egocentric, which means everything is centered around you. And you have a hard time thinking about others, generally speaking, in this stage. And then in concrete, operational stage, you're able to order and classify things together, and you're able to put things into groups, and you're able to sequence numbers, and you can start to learn more interesting math because you can use those groups, right? 4 times 2 is a way of saying 4 groups of 2 or 2 groups of 4, right? And so kids can start to pick that up when they're 7 and 8. Like my son's an 8-year-old now, and so he's actually learning multiplication. That's what groups are, right? That's what multiplication is putting things into groups. So he can do operations like 4 times 2 and 3 times 6 and that sort of thing. Because he can think about it like 3 groups of 6 or 6 groups of 3, right? And he can figure that out now. My 5-year-old can't, right? She's in this pre-operational stage. She can follow one conversation at a time. She gets easily distracted though, right? If you start like throwing a bunch of things at her at once. And then, when you get to the formal stage, you can do some reasoning here, right? You can understand geometry, right, and physics in this kind of stage. And then when you get to formal operations, this is where you can really develop your schemata, right? You can take things that from a whole bunch of different areas and synthesize them together into one coherent whole. So at this stage, you can ask a kid to talk about, um, the causes of World War II or something like that, right? And this kid could actually say, okay, so I learned in history class that World War II was caused by the um, Nazis, taking over Europe, and then they allied themselves with the Japanese, right? And in English class, I read a book about the Holocaust, and in science, we learned a little bit about, like how different weapons were manufactured. And I can put all these things together, right? And I could tell you about them, right? That's a formal operational kind of way of thinking about things. All right, so look at the baby. We can talk about babies again. He's adorable. So the sensory motor stage, right, was from birth to 2 years. And babies are, I don't know why it's hiding my words. Hold on, I can't fix it. Sometimes this sort of reorders my images, which kind of stinks, but babies are connecting their senses to physical action. That's what this is supposed to say here, actions. So they're developing hand-eye coordination, they're moving and manipulating objects. Everything goes into the mouth like we talked about. What they're really learning is that their bodies and themselves are separate from the things around them. And the one thing you need before you move on to the next stage is you need to understand that objects are permanent. So even though you can't see it, if I hide something behind my back, you still go look for it because you know it's there. If you're a 1-year-old and I hide it behind my back, if I show you a ball, right, and you want to play with the ball and you want to throw the ball, you want to put the ball in your mouth, you want to roll it around, you want to do something with the ball, I take the ball and I put it behind my back, you think it's disappeared. You're like, it's out of sight. Oh my God, you're a magician. 2-year-olds, though, if you do that, they'll go hunting for it and looking for it, right? They know it's behind your back. They saw you put it behind your back, right? So once you get that object permanence, you move on to the pre-operational stage. And I broke this up into different age categories here. There's the typical age, from 2 through 7 years old, right? And so I decided that I would talk about, each stage here. That's a big age range, 5 years at this stage. So, what kids do here is they play, dress up and make believe and stuff like that, right? They play house, they have tea parties, their stuffed animals are alive, they're superheroes fighting off bad guys. You know what I mean? It's that kind of play sort of typifies the pre-operational stage. From the ages 2 to 3, everything is why. Kids want to know about all kinds of reasons for things, and they're just like, why? It's also characterized by what psychologists call magical thinking. Magical thinking is the idea that things happen and conclude through magic, just because they are. So a good example of magical thinking is when perfect example of magical thinking is what's coming up soon. Santa Claus, right? Easter Bunny, Tooth Fairy. When your parents say that your dog is going to live on a farm, it's not really going to live on a farm. From somewhere in ages 2 to 4, children start to think in images and symbols, and this is how we end up learning language, according to Piaget, right? Kids are egocentric, like I said before. The kid is the center of the universe. So you'll get presents from kids that are like, well, since I like Sesame Street, my dad must like Sesame Street, so I'm going to make him something Sesame Street and give it to him. And since I like Sesame Street, he's going to love this gift, right? That's a perfect example of egocentrism. So little kids, they get to go to the school store when they're in kindergarten through 4th grade, and they buy their parents things that they like. Or they buy their sister or brother something that they like, right? So their sister and brother is like, I never liked Pokemon. And then the kid's like, yeah, but I like Pokemon, so everybody loves Pokemon. And there's animism too, where inanimate objects, they think are really alive. So this is why kids like dolls and stuffed animals and action figures and things like that, right? Because Just because it's not alive doesn't mean they can't pretend it is. And then there's some curiosity and there's a little bit of reasoning, right? So kids are wildly curious at this age, right? And they always want to know things. And so they're always asking questions and trying to find out answers to things. Um, they really have difficulty with ideas like conservation, where you can change the appearance of something, but it doesn't change the basic properties. So here, let's watch a video and I'll kind of show you what I mean. Let's watch this.
First of all, I'm going to take this water and I'm going to pour it into these glasses. And I want you to help me make sure that I've got the same amount of water in each glass.
So this is a classic conservation experiment. I did this with my kids. One of my kids is 8. One of my kids is, she's just turned 6 now, so she was 5 when I did this. And I did the exact same experiment with the 2 cups, with the glasses of water and everything. I'm not sure what happened to the recording though, so I had to go and find it here on YouTube. But basically, what you do is you pour water into 2 glasses, and you make sure that the kids look and see that it's the same amount of water, right? And then watch what happens.
Is that the same amount of water? Do I need a little more in this one? How's that look? Yes. Is that the same amount of water in each glass? I want to pour some in here. Well, I want you to pour this water in this glass.
Now they're going to pour the water into a smaller glass, right? So we're changing the shape of the container, but not the amount of water, right?
Okay, now, Emily, tell me, is there the same amount of water in this glass and this glass?
So then you ask the kids, is there the same amount of water?
No. No. Okay. This one's big and this one's small. Okay.
So I don't know if you heard the kid there. The kid said no, because this glass is bigger than this glass, right? That's really common among the age group between 2 and 4 or 5 or so, right? Between the 2 and the 4 or 5 in this pre-operational stage, because you changed the way it looks, they think that it's still bigger or smaller, right?
Becca, what do you think? Is there the same amount of water? Yes. Yes, how come? Why?
So the older kid, the 7-year-old, says yes, there is the same amount of water. Now when I did this with my kids, my 8-year-old looked at me and he was like, I just watched you pour it into that glass, so obviously it is the same amount of water. I mean, he's like, duh, right? So this is what I mean by the difference between the 2 stages. And at the pre-operational stage, that's what you get, right? You get kids that are like, no, you changed the container, so obviously you changed the amount of water. Then when you get to the concrete operational stage, the typical age is 7 to 11. This is when the kid looks at you with the water thing and is like, I mean, come on, I just watched you pour it into the other glass, right? I mean, come on, it's the same amount of water. And 4 and 5-year-olds think you're a magician, right? They're like, wow, you're so cool. But these guys between 7 and 11, they use logic. They can understand that their own thoughts are different from everybody else's. They do lots of grouping things and classifying things, right? By size, by weight, by color, by shape. You can ask them to do any kind of sorting that you want. They can use what's called inductive logic, where they can find one example and generalize it to other things, right? So they can make this assumption, right, that all organisms depend on water. Any new life form that is discovered on Earth will also depend on water. They can do interesting things with math, like adding and subtracting and multiplication and division. And most importantly, they can explain why they have come up with a solution. The pre-operational kids, the 4 and 5-year-olds, these guys have a hard time telling you why they think things are occurring. And then the last stage, the operational stage, the typical age range is, once you get to be a teenager all the way through an adult, right? I should make this. Sorry, I got interrupted by a bell there. I had to go back a little bit. And for some reason, my picture got all jacked up in this one. Adobe. But this is what you guys look like here. Come May, right? You guys will be holding your diplomas. It's kind of like pasted over in a place that it shouldn't be, but we will move on. So the typical age range for the formal stage is from teens to adults, although I should mention that there are some adults who don't actually do this stage very well. You know, they don't do deductive logic. Inductive logic was going from specific to general. In deductive logic, you can draw conclusions from a whole bunch of information, and you're able to think in hypothetical situations. That's what deductive logic is. And that's kind of the mark of, smart people can do that. You can engage in abstract thought, right? You can talk about what's ethically or morally right, right? Is it right to do this or wrong to do this? And you could, have two competing ethical principles, and then, make a decision based off of that, right? And you can problem solve, right? You can use methods for problem solving from either trial and error. This is what, like younger kids do, because that's the only thing they know, to hypothesis testing, right? So you can say, well, I think this is how things are going to go. Let's assume that that's going to happen, and then I can try it out. So that's what the formal operational stage people can do. And it's characterized by all the things you do in high school. You can do all these things in order to graduate. And then here's a chart that I wanted to show. It's the percent of kids in each stage. So you can see here's their pre-operational stage. And so, when you're 5 years old, most kids, looks about like 80% of kids are in this pre-operational stage, right? But then by the time you're 12 and 13 and 14, very, very few are, right? These are the kids that have cognitive delays or disabilities, end up being down here, right? Then when you get to the, concrete stage, our third stage, then you start to see, some 6-year-olds are already in the concrete stage. It looks like, I don't know what percentage of 6-year-olds, maybe a third, so 30% or so. And then you can see how it just grows and grows and grows, until you get to be about 10, and then you start seeing a bunch of people in a more concrete, mature sort of stage, and then, the formal stage here, that last one we were talking about. You're going to get more and more kids into that as you get older and older and older. And basically what this shows is that, kids move through these at different stages, but most kids by the time they're 14 are, getting rid of the concrete stuff and incorporating more of that fourth stage, that formal operational stage, right? And so, the older you get, the more these decline and the more the green spaces grow, right? Until you get, when you're in your 30s and 40s, hardly anyone is left in the concrete stage anymore, There are still adults that are, though, I don't know if you know any, but you might know some. All right, guys, that was cognitive development. So when you have questions, make sure that you contact me in class or send me an email or a text or something like that, and I will help you out. All right, guys, let's do some formal operations here, and take good notes and make sure that you use these on the actual test. Okay? All right.